Hi, I'm Michael Awadala, Reproductive Endocrinology and Infertility Fellow at the University of Southern California. The reason we conducted this study was to address a need to perform quality control monitoring for IVF outcomes, such as live birth per cycle start and pregnancy rates after euploid embryo transfer. One of the challenges is that these outcomes are dichotomous, meaning they can be expressed as a 1 or a 0. Evaluating dichotomous outcomes with small sample sizes, such as that of a single clinic, can be challenging. We found it useful to look at the outcomes using a moving average to smooth the data. This is similar to locally weighted scatterplot smoothing, which is commonly used in regression analysis. Most of the manuscript discusses determining appropriate quality control limits for the smooth data. We then give a real-world example of applying this model to our clinic's euploid embryo transfer data from 2015 through 2020 and assessing the rate of fetal heartbeat detection per embryo. We're providing several data files through Mendeley data that can be used by other clinics to recreate similar analysis and to review our methods. In the next few minutes, I will demonstrate techniques that can be used by any clinic to analyze their own data and generate a graph similar to Figure 2 of this manuscript. Although I'm speeding up some of the data analysis, the analysis can be performed by any clinic in about 30 minutes using Excel, or even faster using the provided SAS program. The first step to accessing your clinic's SART data is to log in at sartcoursonline.com. Next, you can go to Advanced Reports, and then All Fields Export. You may need to change the permission settings to access these features. You can adjust the cycle start date range as you would like, and there are some other filter options you can select here, or you can filter the data later. Clicking the export button will export your data to a comma-separated value file. Here I've uploaded a file with all the patient identifiable information removed. First, you can do some formatting to make it easier to visualize the first row headings, and you can also adjust some other features in Excel so that it's easier to sort the data. Next, we're going to sort out the PGT cycles and delete the non-PGT cycles. You'll need to know a little bit about how your clinic records this information and to make sure it's recorded correctly for the filter to be correct. We're also, for this purpose, going to delete cycles without an embryo transfer. All of these steps can be done in other programs such as SAS, but it's a little bit more difficult for me to show how that works than it is in Excel, because in Excel everything is done a little bit more step by step rather than automating it. In this step, we're going to remove cycles using donor oocytes because we'd like to focus on only autologous embryo transfers. We're also going to remove fresh embryo transfers from the data set by sorting and then deleting out the fresh cycles. I find it useful to highlight columns containing key pieces of data that will be needed for the primary data analysis, such as fetal heartbeat, and there are several columns where you may need to look to add up the number of embryos that were transferred. Next, we will create some new columns for total number of embryos transferred, number of fetal heartbeats, and number of fetal heartbeats divided by number of embryos. These are the columns in green highlight here. Some of the formulas that I'm typing in just help to recode some of the missing values, which could represent no fetal heartbeat, to a value of 0, because when there's nothing recorded, the fetal heartbeat data is left blank to indicate that it's 0, but for the data analysis, we'd like to have a 0 if there was no fetal heartbeat. And a quick trick is double-clicking the lower right-hand corner will send the same formula down the entire column for the whole spreadsheet. For the planned data analysis, we would like to reformat the date of embryo biopsy as a year in a decimal number format. So for example, we'd like to express July 1st, 2020 as 2020.5. So for this, we create another column with the date of January 1st, 2015, and then apply the formula here to calculate the difference between that date and the date of embryo biopsy. We are including in the references a direct object identifier link to a Mendeley dataset with files that can be used to recreate the analysis for the manuscript. There's a SAS file that can be used to filter the data, performing the steps I've shown here, and there's some MATLAB files used to recreate the statistics. There's also this Excel file that can be used to copy and paste the filtered data with the year of embryo biopsy and the outcome in order to graph and recreate the quality control charts that we've discussed in the paper. It is important to use the paste values function to transfer over the data, otherwise the formulas will be pasted and the numbers won't carry over. There are some additional formatting steps needed, including deleting any parts of the moving average where the average extends beyond the end of the data. This Excel file initially contained the data used to generate the weighted or smoothed moving average shown in figure 1b, and we are now giving an example of how we uploaded the data for figure 2 of the paper. For the data in figure 2 of the manuscript, we performed additional air checking of the data and excluded embryos from frozen oocytes. For that reason, the data graphed here is very similar to, but not exactly identical to, the data graphed in figure 2 of the manuscript. Thank you for showing interest in our research and for taking time to watch this video. Please do not hesitate to contact us with any questions or to discuss these research topics further.